In this video, we'll discuss the multiplicativity of phi, Euler's totient function, and we will derive it from the formula of Euler's function. At the same time, in one of the following videos, we'll derive the formula for Euler's function from the multiplicativity. Please do not be concerned about these proofs. We have independent proofs for both multiplicativity of Euler's function and formula for Euler's function. So these proofs are mostly for the clearing of the connection between these properties of Euler's function. Well, what is multiplicativity? It is the property of phi of the product of two numbers being equal to the product of values of phi of these numbers. So as you can see, there is an additional condition which must be fulfilled, that these two numbers must be mutually prime. So if n and m are mutually prime, then phi of nm is equal to phi of n multiplied by phi of m. So let's see how this follows from the formula for Euler's function. First, take n and decompose it into prime factors and use the formula, write down the formula for phi of n. And then take m and decompose it into prime factors. So we have prime factorizations for n and m, and these prime factorizations allow us to write formula for phi of n and phi of m. And now notice that if n and m are mutually prime, then these two sets of prime numbers have empty intersection. Well, clearly, prime numbers that are divisors of n cannot be divisors of m, and the other way around. So if we take the product nm, we will have a prime factorization that literally consists of both prime factorizations of n and m separately, with something like a concatenation. And all these primes are distinct. So if we take the value of Euler's function for the product, then we will see the number itself, nm, multiplied by 1 minus 1 over prime number for all these prime numbers. So just take a look at these three formula. I believe that now it is obvious that the lower one is equal to the product of the upper ones, which means that Euler's function is indeed multiplicative.